Welcome back to my channel, Pachehra Talks. My name is Arun and I'm a solutions architect with Rackspace Technologies. This is my channel and these are my views on stream analytics. Yes, so today's topic is design Azure Stream Analytics solution for data analysis. Well, it seems pretty interesting topic, yeah, because we are covering 305 and we are in the data modules, and this is the one of the most important and interesting. So let's continue by understanding things. What is the thing here? Azure Stream Analytics. So what is analytics? Azure Stream Analytics. Well, the process of consuming data streams, analyzing them, and driving actionable insights is called stream processing. Okay. Now, that's how the stream is coming, but analyzing them with the help of Azure tool or Azure Stream Analytics, that is a tool itself. So that's what the Azure Stream Analytics. What we are trying to understand here, the very first thing is, what is stream? The continuous moving data, just like water stream, we are talking about data stream. And with the help of Azure Stream Analytics, we perform the analytics on that streaming data. So if we need to come back on stream processing, what is stream processing first? So the process of consuming data streams and then analyzing them and delivering, because once you analyze, you got to do something with it, right? And we are talking about real time here. So you can take a very good example of, let's suppose there is a nuclear reactor, which is sending lots of heat signals, and you have to perform the analytics on the real time, and you have to perform the action as per the analytics. So the third point is actionable insights. Just for basic understanding, keep this in mind. Data is coming in the form of data stream, then we are performing analytics on it, and as per the results of the analytics, we are performing some actions on it. Just an idea, because you will understand as soon as we started understanding the architecture. There we go. A very simple architecture here. As you can see, data is streaming. Right now, data is coming from event hubs or maybe IoT hub to the Azure Stream Analytics, and then it is moving to the Power BI streaming dashboard. It's a very simple, basic example. This is not it. There are like so many things that we can do or perform with ASA. So many different kind of architecture is there, but this is a very basic to understand. So as per this reference architecture, you could see there is a data stream. However, if we go further, then there would be a source who is sending data to the event hub, or for example, IoT devices is sending data to the IoT hubs. So data is continuously generating by the different things, like I said IoT devices, right? And there could be different telemetry that we are sending into the event hubs. So there is event sources from where the data is coming into event hubs, and from here we can go and perform the analytics with the help of ASA and then send the output to somewhere. All right, so now it started grasping into your mind a little bit, but as soon as we go ahead, you will understand all. So by keeping this concept in mind, let's try to understand on what concepts this ASA or Azure Stream Analytics works. So data stream, You can guess it now, right? Because that's all we are talking from here. Data streams are continuous data generated by applications, could be IoT devices or sensors. And these data streams are analyzed and actionable insights are generated or extracted from it. All right. Stay with me. Very simple. Data is coming out of the IoT devices or applications. We are performing analysis on it. And as per the results, we are taking some actions. That's simple. So the concept of data stream. Let's take another example. Monitoring data stream from industrial and manufacturing equipment, monitoring data of water pipelines. We recently did this detailed design for one of the organization that was doing this water pipeline, and one for the railway as well. So the data is coming from those utility providers, and as per the analytics, we are performing action on it. It could be good, it could be bad, but it will help us to take the actions. It will provide us a deep insight, which will help us to take right action on right time. And this data stream, the first concept, another one is event processing. Yes, because without event processing, we cannot get data in for the analysis. So what is event processing? Event processing refers to consumption and analysis of a continuous data stream to extract actionable insights, again, from the events happening within the stream. So data is coming, then we are processing. That's simple. Now, let's give an example of event processing. We can say like there is a vehicle which is passing through a toll booth, and it includes temporal information such as timestamp indicating when it occurred, right? So if you go with this example, event processing refers to consumption and analysis of a continuous data stream to extract actionable insight from the events happening within that stream. That's all event processing. Now, if we take an example where car is passing through a toll booth should include temporal information such as timestamp indicating when it occurred. So you can analyze out of all the data, the temporal data you can pick and do your thing, action. Now, the next thing I'm going to show you will help you understand everything what we are trying to construct or put together. There we go. This is a wonderful, wonderful mind map, I would say, or architecture provided by Microsoft for understanding. Now, you could simply see here with the help of this design, these are various event sources. These are various event sources. Like I was saying, IoT devices, log files, customer data, financial transactions, weather data, business apps. And this data is ingested into IoT hub or blob storage or event hubs. What it means stream analytics can work data coming from or streaming from event hub or blob or IoT hub. It supports all these three. Plus you could have the reference data for your table joining. All right, so data will come here and then it will stream, then the analysis happen. And the output, once the analysis is done, what we were using again and again, actionable insight. So what it could be alerts, it could be actions, like we could send the data to the event hub, service bus, function trigger. We could have the Power BI or data warehousing or archival. It depends. So if we need to conclude this, let's try to understand with the key features. This is the architecture. This helped us to cement the old knowledge. From last 5 minutes, we are just trying to understand ASA. So ASA actually stream analytics ingest data from these sources, as I said. And then here under this place, query runs, query happens, and the output send here. Why I'm repeating myself? Because now you will understand what is happening here. There is an input, there is a query, and there is an output. That's why I was repeating myself. So Azure Stream Analytics job consists of input from Event Hub, Azure Blob Storage, IoT Hub, and then there is a query that the data engineers write there, and then there is a output. Output could be sent anywhere as per the your design or your need. So yeah, that's it. Now let's go ahead and see what we have next. Now we tried to understand a lot of things here, and I hope the concept is clear, but we need to understand when we need to use this kind of architecture, when we need to use Azure Stream Analytics, how we use it. It runs on input, query, output. It supports IoT Hub, Event Hub, and Blob Storage. And source is sending data to these hubs and blob, and then stream comes to the ASA, then query runs, and output goes to the various other output sources and actionable insights. That's the keyword here. All right, so now when we have to use this, when? Well, these are few, this is not it. There are few selected scenarios that I've picked, like gathering real-time sensor data in Azure Stream Analytics from building automation system relying temperature, humidity, fan runtime, and making adjustments to maintain optimum building temperature while reducing cost. So we could simply say real-time analysis, a real-time analysis of real-time telemetry. And as per the analysis, you can take the actions. Now, web logs activity, the very good example is, let's suppose a consumer goods retailer can offer real-time product suggestion to user based on e-commerce analytics, like as per the browsing logs information, analytics can happen then and there, and recommendation can go real time again. Now, third is geospatial and analytics. I'm sorry. Now, this helps in various ways, as the word geo specifies. So you could simply understand data sources include sensors, social media, satellite imagery, mobile devices, etc. For example, extreme weather prediction of wildfires and hurricanes can help airlines with routing and send out alerts of adverse weather condition to people. So those kind of analytics can happen under this. And if you're looking for predictive maintenance, well, monitoring high value assets such as industrial equipment by gathering operational data in Azure Stream Analytics and maximizing the useful life of their equipment can be achieved through predictive maintenance. Microsoft does that for the VM hardware. We can have another example like data gathered from electrical power transformers used by utility companies. Now, this one is interesting. You all have seen that, where real-time analytics on sale. It is more like a credit card fraudulent transaction. For example, if you are doing unusual transaction from unusual location, then they could be an alert triggered, and it happens with us all the time, right? If you are not doing this transaction, then you can block it, things like that. So that is also real time, and we need real time in always security related things, always. So these are a few examples where we could utilize AES, or we can consider utilizing ASA. There are like various other tools that you can, of course, like Azure Databricks, Agent Insight, Spark Cluster. There are so many, but we are talking ASA or Azure Stream Analytics. So yes, you can think for Azure Stream Analytics. But why would we think for Azure Stream Analytics if there are so many tools around? Let's check some benefits for that. All right. So these are a few benefits then that will help us to make our case strong when we talk about Azure Stream Analytics for one of those situations where we can utilize the benefits of ASA. The very first is it's fully managed. And we all know what's that mean, right? It is a PaaS service. So there is no overhead of provisioning any hardware or maintenance of hardware or infrastructure for analytics. So Azure Stream Analytics fully manages your job so you can focus on your business and not on the infrastructure maintenance. Low cost. Well, billing is done by streaming units, SUs, consumed, which represents the amount of CPU and memory resources allocated. Just like in data warehouse, we have DW, and in SQL, we had DTU. Similarly, here we are doing Azure, streaming units, SUs. And this is the CPU and memory ratio. Now, scaling up and down are based on the business needs, which can also bring cost down. No maintenance costs are involved, of course. So low cost. It could run in cloud or IoT Edge or Azure Stack. So yes, that's pretty good. Now, performance. Stream Analytics offers reliable performance guarantees. It supports higher performance by partitioning, allowing complex queries to be parallelized, not paralyzed, parallelized and execute on multiple streaming nodes. Stream Analytics can process millions of events every second. It can deliver results with ultra low latency. Security, well, this is very important and you will be happy by knowing in terms of security, ASA encrypts all incoming and outgoing communication and supports 1.2 TLS. Built-in checkpoints are also encrypted. Stream Analytics does not store the incoming data since all processing done in memory. Right, so these are some benefits that could help you. And finally, we were talking about streaming units. So let's check it out. So what is streaming units or SUs? Well, as you can see, we have already talked about it. It represents the computing resources that are allocated to execute a stream analytics job. Higher the number of SUs, the more CPU memory resources are allocated for your job. And this capacity lets you focus on query logic and abstracts the need to manage the hardware to run your stream analytics job in a timely manner. We already seen that in the benefits. So there are 3 SUs by default, and it could go up to 192 SUs. And to achieve low latency stream processing, ASA jobs perform all processing in memory. When running out of memory, the stream job fails. So you gotta enable the alerts for it. All right. And yes, I think that's all about ASA as of now. And let's meet in another video. And just wanted to add one more thing. ASA supports processing events in CSV, JSON, and Avro data format as well. And the query that you use for the analysis is SQL language, and with JavaScript and C#, you can also define some functions, UDFs, user defined functions. So yes, that's very interesting, and it is a very high level understanding video. For this 305, that's all about it, to be honest. But yes, I would like to go into the windowing and other stuff and see a couple of architecture if we could. But for 305, it is okay. But when we try to cover the data or DP 203, it will be pretty deep. All right. Thank you. Take care and bye-bye.